and start the recording. Good afternoon. This is Julie Bloomquist, and I'm one of the moderators for the past database administration virtual chapter. Today we have a lecture from Sharon Dooley, a few of my SQL Server 2016 favorite things. We have a whole list of virtual chapters which are available through PASS. You would just go to your PASS membership and associate your membership with a virtual chapter, and then you'll get the emails about the upcoming meetings. Most chapters do meet at least once a month. We have some upcoming SQL Saturdays. These are one-day mini conferences located in cities throughout North America and also internationally. The costs are minimal. It's usually just to cover the luncheon expense. Don't forget, we do have PASS Summit coming up. This is the big SQL Server conference. It is being held out in Seattle again. There are 2 days of pre-conference sessions, so those are one-day classes as well as the PASS Summit. The registration now is $17.95 until April 18th. And if you have not yet registered, if you use the code VC15FPS6, you'll be able to save $150 on your registration. The discount can only apply moving forward, not retroactively. There are also physical chapters. If you go out to the PASS website, you could find the physical chapters as well as the virtual chapters, and if there's no user group, there is assistance in setting up a PASS physical chapter. You can contact PASS and they'll help you with that. There are a lot of volunteering opportunities with PASS. It's a very large organization, and if you go out to the website or do an email, they should be able to help set you up with volunteering. And there's also an Outstanding Volunteer Award. So if you know someone who's been very active in the PASS community or your SQL community, send in a recognition for them. You can stay active with PASS through LinkedIn, Facebook, and Twitter, also on the website. So today, like I said, we do have Sharon Dooley. It's a few of my SQL Server 2016 favorite things. Sharon's been working with SQL Server since its first release. Her major areas of specialization are database design, performance tuning, and she has a consulting practice and teaches and writes courses for the Learning Tree International, where she's a SQL Server curriculum architect. Sharon is an active member of PASS, and she also leads this DBA chapter. So Sharon, I'm going to pass the presentation.
Make me a presenter. Thank you.
Okay, do you have it now? There you go, and I can see your slides.
Good.
Oh, I did want to announce that this is being recorded and will be posted on the DBA Virtual Chapter Archive webpage.
Hi, everybody. Microsoft sent us a bale of slides that they wanted the virtual chapters to present because they just announced general availability of SQL Server 2016 last week. And so I did some spelling errors and tried to pick out things that I thought we could cover in the hour we have together. And they are things that I'm really excited about. So the first thing is the enhancements to in-memory OLTP, the technology that was codenamed Hackathon. And these are huge differences, mainly in usability. Being able to finally alter a table. In SQL Server 2014, if you wanted to make the slightest change to a table or an index, you had to export the data to somewhere, drop the table, recreate it, and import the data, which was a pain in the neck. And now you can not only alter the table, but you can also alter the indexes, so that if you've got your bucket count wrong for your hash index, you can simply rebuild the index with a new bucket count. And there's a lot of improvements in the amount of T-SQL that you can use in natively compiled stored procedures. And we'll talk more about that part in a few slides. Now, this is the syntax. You can't use a standalone alter index statement. Okay. It has to be alter table, alter index. But you can do all the other things. You can add and drop constraints as well. And there's more support for constraints in SQL Server 2016 as well, which means that you're going to have to write less code if you're dependent on having the constraints in place to protect your data integrity. The other thing you can do is alter natively compiled stored procedures. And this is big because with SQL Server 2014, what we ended up doing, because you had to drop the stored procedure, when you drop the stored procedure, you lost all the permissions. So you ended up writing a wrapper stored procedure that simply invoked the natively compiled stored procedure and putting the permissions on that. And now you can alter them just like any other kind of stored procedure. And I am so glad to see that we can do all of these things.
So,
Full outer joins.
Sharon, could you
Yeah.
minimize the GoToWebinar? The sidebar?
Yeah, wait a sec.
There, that's great. And then, yeah, do that slideshow. Yeah, thank you.
Yeah, thanks. We have more use of execute as. We have natively compiled stored procedures can now be nested. You can have the set of all of the outer joins and union. There's subqueries. I haven't been able to find out if CTEs are included, but I would expect they are because they're just basically the same thing as a derived table in a subquery. I haven't checked that out. And they've also provided support for more collations. In SQL Server 2014, if you wanted to build an index on a character string column, it had to have a particular collation. now that restriction is eliminated. And they've enhanced, they've got multiple threads dealing with the persisting of the memory optimized tables. There's multi-threaded recovery. They've changed the dynamic management views, and DBCC CheckDB will support a 1 terabyte database and improved by 7 times. Now that's on the slide I got from Microsoft. I'm trusting that DBCC CheckDB actually works in SQL Server 2016 because it has some major problems with in-memory tables in SQL Server 2014. So you can check it out for yourself. And then there's this. You can run the transaction performance analysis report to pinpoint hot spots in the application, and it's my understanding that it's no longer necessary to set up the management data warehouse in order to be able to use that report. And there's also some ways of getting more checklists for what will allow you to, what you are interested in migrating. And you can do that with the GUI, or you can do it with PowerShell. Okay, before we go on with the next topic, are there questions about about the in-memory OLTP? I just realized there's an elephant in these slides. Look, in and among the ones and zeros, there's what I think is an elephant.
Yeah.
How weird.
It
How
reminds me
weird.
of
In
Hadoop.
particular, and I hope it's Hadoop and not dealing with politics.
So yes, I don't see any questions.
Okay. Now, this query store I'm quite excited about, and I actually did an hour presentation on it for SQL Saturday, Philadelphia SQL Saturday last Saturday. I first learned about it at the past summit in 2015. And I went to a presentation, and it was something I really wanted, and you could only have it if you were using Azure SQL database. And since I don't really believe databases belong in the cloud, I was very annoyed. But now I have it in SQL Server 2016. And Microsoft describes this thing as the flight data recorder for your database. Okay. I think that's the wrong way to describe it, because we already have a flight data recorder, the black box recorder, because now we used to have a profile, a trace that was always running, and now we have an extended event session that's always running. So this isn't really a flight recorder. It's really a persisted plan cache. Okay. And its goal is to help you fix performance problems. And you need to find, you're worried about things like plan choice regressions. That can happen because the plan that was in the cache is not appropriate for a particular version of a query. Or it can happen when the optimizer changes, when you have a new version of SQL Server. It can take a long time to detect the issue, okay? And you know, you've been there. I'm sure you've all been there. Every DBA's been there. The user is on the phone and screaming, "My query is slow," and or the hourglass is on the full time, or whatever. And it's hard to figure out which query is slow, why is it slow. And then it takes time to modify the query. How to do it? How can I do it? How can I solve this problem? And if you've ever been faced with that, you know you have to do a whole lot of analysis to figure out whether there should be bigger, better, different indexes or whatever. And the plan choice change can cause these problems. Now, this is a better description. The query store is a dedicated store for query workload performance data. And it captures history. It captures history of the plans and captures performance of each plan over time. And it persists the data to disk, which means that the information is available even when you restart SQL Server. Okay. Now, where the information is stored is a mystery. Okay. As usual, it's hidden somewhere. But there are ways of accessing the data. And I'm going to show you some of it, but it makes it easier to discover and to fix performance problems. Now, the thing that I notice is that Microsoft's basic solution using this tool to fix a performance problem is to force a better plan, a plan that got better performance. And that's what they're talking about here. Force previous plans from history. Whoops. Come on, come back. And in the short term, that's the right answer. But I don't think that's the right long-term solution. I think that'll get you going, but I don't think it doesn't mean the problem won't come back or have a varied flavor. And so you're still going to have to do this, the process of figuring out what the best indexes are, what the what will cover the query, things like that, all of your standard index design analysis. But it does mean that the user on the phone can be pacified and made to go away. Now, One of the things that this slide doesn't say is that this is per database. The query data store is inside a single database. And you turn it on at the database level. And it's active from the time you turn it on. When you compile your query, certain tables in the query store get built. And then when it's executed, there are runtime statistics collected. And there's a whole bunch of database options you set up that control how much data you're willing to risk losing, control how frequently the data is flushed into the query store, and so forth. And this is what I meant about they're totally hidden away. Okay, I have no idea where those tables are. What happens, it does capture the data in memory to minimize I/O overhead, and it's persisted to disk asynchronously. Now, one of the things I was looking for when I was working on my SQL Saturday presentation was some information about what kind of load this query store puts on my production server. And I have not been able to find any of that information. And I wish I could, because whether or not it's going to be useful, that can make the amount of load it's going to put can make a tremendous amount of difference. And so, like, we all abandoned using SQL Profiler because its hit on the server was so expensive. And we can query this with some views that merge the data that's in memory and the data from the internal tables, and the users always see the latest data. Now, you get one row per query per plan affecting context settings. Now, you're probably aware that some of the set options you can put in your query window, like ANSI null, changing the setting of ANSI nulls, changes the plan for the query. And so you may have, depending on somebody in one window has one version of set options, and a user with another window has a different version, you will have one entry for the query text. I wish I didn't keep losing my mouse because I want to use it as a pointer, but it's not cooperating. You'll have one query text, select star from table. But there may be several entries in the query box because of that same query having been run under different settings, different set options. And then there'll be a plan. And the plan is essentially what you would see if you did a show XML plan. Okay. And so there's going to be one row per plan for each query. And so all of those blue boxes are what are collected at compile time. Okay. When you send your query or your stored procedure or whatever to the query optimizer for plan development. And then the purple boxes are runtime stats. And so if you have a plan, there's going to be one row for each time interval. And the time interval is you specify when you set up the query store. And so those are the internal tables, and you're going to be querying them through the exposed views. Now, there's a if you go to code,
Hey Sharon, I've lost your sound.
and so
Whoops, it's
you
back now.
lost my sound.
No, it's back now. I hear
Okay,
you.
all right. So at CodePlex, there's a series of query store samples, and it's a file of some awesome code revealing things that you might not get intuitively through looking at the graphical tools. Now, what this first sentence means is query optimizer enhancements are tied to database compatibility level. And that's not at all unusual. Okay. And so the idea of what we're talking about here is how to deal with that painful process of upgrading to a new version of SQL Server. Okay. And so what they're saying is you leave let's see, SQL Server 2016 is 13, I believe. So you leave it at 12 or whatever version of SQL Server you're running. We're running before the upgrade. You run the query, get a query store, and create a baseline, and then move to the next level of compatibility and fix regressions with plan forcing. Now, there's a little thing they didn't even mention in here, but one of the things I think is useful to do when you install a new version of SQL Server is to update your statistics. Okay. And I'd probably want to do that and then do the query store and then the B.next compatibility level and all of that. Okay. Now, this is one of the built-in reports that you can see in Management Studio. And this is the top 25 resource consumers during the last day according to this slide. And you can look at duration, CPU time, logical reads, etc. And you can see, you can highlight one of the bars and you'll see the plan, and you can compare the plans. And then if you want to force the plan, you can have a button that you can click. And this is just one of the reports. I didn't plan to do any demos, and now I'm kind of wishing I had done some demos. But it's too late to set it up now. As I said, you have to turn it on. And you'll notice it's turned on with an altered database. And it can be done in any database except master and tempdb. It can't be in either of those databases. And you can look at the defaults by selecting the options. The default operation mode is read-write. Okay. That you're going to be wanting to monitor this, because if it reaches its max size, it will become a read-only operation mode. And you have to set your cleanup policy. This is when do you consider a query stale? A query this is using 30 days. That's probably reasonable. A query that was busy a month ago may not even be used at the moment. And you can specify the data flush interval in seconds, and to some extent the smaller that is, the more it will be interrupting to write to the permanent query store tables. So you're going to need to do some playing with that to find out what works best for you. And then you specify the maximum size of the query store. And then this is that interval. And that's what we're talking about here. Okay? The runtime statistics will be collected at that frequency. So this is saying I'm going to collect runtime statistics every 15 minutes. And if it's getting full and you can clear it out, you can also, there's a stored procedure you can use to selectively remove queries. And there's also, in the CodePlex sample, a query code that will remove all the ad hoc queries. Okay. And there's a sample of a query using the query store views that will give you total number of executions. Now, this is a sexy little thing. Doesn't really have to do with the query store at all. It's a live execution plan. And it's one of those things that's very sexy for a demo, and so you get to see the little things walking through the plan. Okay, and it requires some setup work on your part before you'll see this little plan. You need to set statistics XML or set statistics profile on in the target session, and you need to enable the query post execution show plan extended event. There are some limits. It doesn't, you can't use this on queries using column store indexes. Queries with memory optimized tables are not supported, and natively compiled stored procedures are not supported. That's no big deal because there's no plans for natively compiled stored procedures anyway, so the idea is that this is going to help you quickly find and fix performance issues. One of the things they didn't list in their reasons for using it was before and after testing. You've got your data application before change and your application after change, and you're trying to compare and see if you've made anything worse. So that's the end of this section. Are there questions?
No question, Sharon.
Okay. Now, I said it was my favorite things, and I really am basically into performance, but so much of my work has involved very stringent security models, and I have had to implement a lot of row-level security with code, okay, primarily views. And Microsoft's been working on this for some time, and I even spent some time. I had a couple of solutions, and a couple of us were working with the security team at Microsoft to try to come up with something that could be a generic solution. But what we came up with in order to be sure it was really secure did not perform really well. So we sort of abandoned it. We abandoned it. But it's a common scenario. Okay. I'll tell you about the one I had. One of the ones I had. I was working with an organization in Philadelphia that helps low-income people with the cost of energy, water, heat, electricity. Okay. And they had the funding for this came from a variety of sources: the city water department, the electric company, the gas company, etc. And obviously, the gas company didn't want the electric company knowing anything about what it was doing, and vice versa. And then there were some other restrictions where, depending on where the employees themselves were restricted, depending on their position in the organization. Okay. And some people could see only demographic information, but not anything to do with money. And other people could see demographics and stuff to do with money. And then there were power users who could see everything. And so this kind of application was has been one of my specialties. I don't know how many years ago I actually gave a talk on row-level security at PASS, and it was the first session on Friday after the party on Thursday, and I think there were 3 people there. Now it's something that's built into SQL Server. And the idea is to give us fine-grained access control over specific rows in a database. Now, I built these solutions with views, okay? And sometimes I had to build other things, other tables, so that I could keep track of, who was allowed to see what. But basically, we're trying to keep, if we have multiple users in the same database, like the electric company and the gas company, we want to make sure that the electric company can only see its data and the gas company can only see its data. Okay. So it's transparent at query time. Once you put in the row-level security, your applications will not change. Okay. And it's in the enforcement logic is inside the database, and is schema bound to the table. It protects, providing greater security. And because it's in the database and not in the application, it reduces the amount of complexity. So we have a few concepts. Okay. First, we have a predicate function, which I'll show you one, okay, where you actually specify, it's an inline table valued function, specifying your logic, your security logic. And then there's a security predicate, which binds the predicate function to a particular table. Okay. And then there's a security policy, which is a collection of security predicates for managing security across multiple tables. And we're going to see these particular pieces going forward. And what this is a hospital application where users, nurses, for example, can see information of patients on the wing in which they were serving during the time they were there. Okay, so if Susie was serving on wing A from 7 p.m. to 7 a.m., she can see patient information for that period. But Joe, who was on the same wing, but from 8 a.m. to 5 p.m. can't see the same information that the other nurse can see. Fortunately, inline functions are the only safe kind of function because they are optimized just as a view would be optimized. So the performance should be pretty good. Now here's our security function. Okay. And it takes an input parameter as the wing of the hospital, and it returns a table, which is simply a single value. But notice it's joining the staff duties table to the employees table and finding out who the current user is and who's on that particular wing. So you can build your function with whatever you need to do. Okay. And then you create the security policy and you add the filter predicate, tying it to your security function. Now, this says row-level security in 3 steps, but they didn't provide the step 1 on the slides they gave us. So I decided that this must be step 1, which was setting up the security function and the security policy. That may not have been what Microsoft intended, but it made sense to me. So then the nurse selects from the patients table. Okay. And that select star gets put together with the security function, and the query gets rewritten so that to apply the filter predicate. And this creates a policy leaving it disabled. Okay. Creates a function and uses the application user which is stored in context info, and at this point it is disabled, and you will have to go and enable it when you're ready for it to be put in place. Okay. And this is, I think, the most common. This is which rows each user can select, insert, update, and delete based on their role, their department, their security level. And that's where all this stuff is. Okay. Finance, insurance, healthcare, energy, government. Multi-tenant databases. Various reporting tools and subsets of data based on their identity or roles. I think this is a good thing. I'm looking forward to having an opportunity to play with it and see how it works in reality. Um, Again, I have the release to manufacturing has only been out since last week, and I haven't had much time to mess around with it. Now, are there questions?
We actually do have a question this time. Is there
Okay.
a fine grain control for columns as well, or just rows?
I haven't seen it for columns. Um, and since you can't apply row level security to views, your usual method of of hiding columns isn't going to work. However, there's quite a bit of other security stuff in SQL Server 2016, and there's a lot of different methods now of encryption, which may solve the problem you want to solve. There's also something called dynamic data masking, where you send data across the wire. For example, instead of sending the credit card numbers across the wire, you send them across with only with asterisks instead of except the last 4 digits, things like that. So row-level security is not oriented to the columns, but there may be other tools that will solve that problem for you.
That's it for questions.
Okay. Well, let me fly through this. I'm not going to be able to answer any questions, but I'll give you a sense of what this is about. Okay. Because I'm almost out of time, but I'll fly through it. And this is a strange beast. And I'm not sure this is implemented the way it should have been. Okay. Because things like this seem to me to be something that could be gotten out of the transaction log, and rather than having a whole duplicate set of data. But they didn't ask my advice, and so this is what Microsoft has built. It's a history of data changes. Now, I've built things like this, and it's nice not to have to do it, because it is a lot of work to build, particularly if you're trying to be able to capture things for auditing. And you have to create a table and alter a regular table, and then you're querying the temporal data, and you're querying in general if you want to see for a specific time period, you have to indicate what time period you want. And so in the middle, you don't have to make any changes in your programming model. And you may get new insights. Find points in time, correct information, when did this happen, etc. And it's basically we have an actual data And then we have a history table. Okay. And the old versions are in the history table. Regular queries only see current data. Temporal queries see the history. There's time flows forward only. Okay. There's no future does not exist. Project future events, etc. So you can go all the way through, and it will give you extreme OLTP with cost-effective data history, and there's an in-memory buffer, and the historical data is disk-based. So it greatly enhances developer productivity, and adds the capability of auditing and so forth. And I thought there was a picture in here of combining it with stretch database. Okay. There. This is the picture. The idea here is that this is your current data. This is your warm data, few weeks, few months. And then you stretch the database out into SQL Azure database. And that's where your cold data lives. And so the combination of temporal and the stretched database is a very powerful thing. And since you're only putting old, cold, historical data in the cloud, it's not so dangerous. All right. So, come on, PowerPoint. That's the end of my slides. Are there questions about that part that I just whizzed through?
This PowerPoint, Sharon, you could share the slides with me so I could upload them as well.
I'll share them with you.
So the slides will be posted on the DBA virtual chapter on the archive page as well as the recording. And one question about the temporal is, can you show up what temporal table looks like and how to import into Excel? I want to use it in Power Map.
According to what I've seen about this, the table will look exactly like what it has and your queries against it won't change. But let's see if we can. So this is your regular queries. with current data. Am I showing my screen? Yeah. And so if you want to get it into Excel, it would be exactly what you do with any other data you want to put in Excel. And it's just a question of how you form the query as to whether you're getting this data or the data from the history as well.
And Sharon, do you have an email address that if there's one person who is asking if they had a question after the session, how to email you?
I think it's written on washroom walls for good SQL email, Sharon. I'm just trying to find a place where I can type it. Email me. Please please tell me you had a question about it from the DBA VC, because I do get a lot of unsolicited email, and like somebody at Deloitte Touche once emailed me his entire schema and wanted me to comment on it. And I wrote back and said, do you have any intention of paying me for this service? And he never wrote back.
I got another question. Power Map allows time-elapsed recordings of temporal data.
Okay, you're outside my area of expertise. I'm a database engine person, and so I don't know all of these business intelligence concepts, and so that may not, the two may be totally unrelated.
Well, that's fine. That's all for the questions. Sharon, I really would like to thank you for the presentation, and I will get the recording posted as well as the slide deck, and I really appreciate all your help in running the DBA virtual chapter. You know, without you, I'm not sure
Julie.
it would be as organized. And we'll see everybody at the next meeting.
Yep. Okay.
Bye-bye.
Thanks, Julie. Bye-bye.